Well, I've been wanting to talk about Hubble redshift models, but I thought I'd start with the Big Bang model. Because while Big Bangers are usually all smug saying our redshift model works and your tired light theories are garbage, their theory doesn't work either. And if they don't know that, then they should, and maybe they should watch this video. The Big Bang assumption is that the Hubble redshift occurs because it's Doppler redshift, so that it's proportional with distance due to constant expansion. Never mind that expansion's easily debunked as I have, because Einstein's infinitely divisible space-time ether with dimensions and clocks is now and always has been purely imaginary. It's a fictitious substance, and so it's a fictitious theory. And then even if you believe that, the Tolman test, which tests the size and brightness of stars in an expanding model versus non-expanding, shows that either we have normal-sized galaxies in a non-expanding model, or we have impossibly tiny and bright galaxies in an expanding model. And so the Tolman test disproves expansion. But assuming you still believe in expansion and expansion-related redshift, you still have a problem. Because, as I pointed out in another previous video, as in response to a PBS video that said the same thing, galaxies aren't expanding. Galactic clusters aren't expanding. Stars and black holes aren't expanding. If you try to do a Einstein-style gravitational space-time media solution to a black hole, you can't have a black hole contracting, leaving a faster than light or light speed event horizon while expanding at faster than light at the same time. You can't do the two solutions at the same time. So the entire universe expanding faster than light solution doesn't match with black holes. It doesn't match with regular stars either. They can't expand faster than light. The galaxies aren't expanding faster than light. We can observe that, and neither are the galactic clusters. So what astrophysicists will say is that they have to have a gravitational solution in regions where gravity dominates and expansion in regions where gravity doesn't. But the problem with that is that, as I pointed out in another recent video, molecules, crystals, atoms, particles, none of them expand. And that's not a gravitational metric situation going on. That's the electromagnetic forces, weak and strong forces. So when you have gravity, electromagnetic, weak and strong forces dominant, there is no space-time expansion. The space-time metric solution doesn't work. And you have to have a regular space solution working at that point. But things get worse because you have nebula that aren't expanding. And we see plasma filaments between galaxies and stars everywhere. And they're under electromagnetic forces and they can't be expanding either. And so you have a picture of the universe with all these filaments everywhere under electromagnetic interactions that aren't expanding. And so what is expanding exactly if none of this stuff can be expanding? Or none of it is expanding because we observe it's not. And it doesn't leave a whole lot that could be expanding, causing redshift. And to the degree there is, redshift is going to be proportional to density, inversely proportional to density. The denser the matter, the lower the redshift. And it is going to be different in different directions and in different distances in different directions depending on the density in that direction, depending if you're crossing a large void where the density is lower. And so in this respect, we could talk about the tire light models that have an interaction where a photon interacts with the particle, causing it to slow down and lose energy and causing it to redshift. Well, those models are energy dependent too, and the Big Bangers are always willing to criticize them for that. Well, the Big Bang model is just as density dependent as any of the tire light models, and maybe even worse, might be much worse. It may be that there's so much material there, even in voids, that there's no space for there to be expansion occurring, because everything's under electromagnetic interactions all the time that prevent the space between particles expanding. So that's really what I wanted to say about the Big Bang redshift model, that their redshift model doesn't even work. And they shouldn't be smug and proud saying, oh, our model works and tire light models are crap. Because, well, the tire light models have a lot of the same density type issues. In fact, I think just about every model does to a degree. But we need to find a model of the Hubble redshift that varies in proportional to distance in a regular way without a high degree of density dependence. And that would be ideal. And I will talk about the redshift models in a coming video in the next week or two. So thanks for watching. And if you like the video, please like, share, and subscribe. Liking it helps with the YouTube algorithm and helps other people see my video. And if you'd like to learn more about my quantum field theory research and particle theory research, I have some books for sale. And thanks to all my PayPal and Patreon and super thanks supporters. I appreciate it. And thanks for watching.